Hello everyone. Today we're talking about trigonometry with CAST, or known as ASTC. Before we begin, we'd like to go over a couple of basics. So first of all, in grade 10, when we learned about trigonometry, sine, cosine, and tangent, we used the acronym SOHCAHTOA. This basically helped us organize which of the sides to label, right? Opposite, adjacent, and hypotenuse. In grades 11 and 12, we actually end up using something a bit more useful in terms of x, y, and r. X, of course, being the x coordinate, y being the y coordinate, and lastly, r being the radius, or in this case, we're going to use it as the hypotenuse for the triangle. So rather than using SOHCAHTOA, we're going to be using these new ratios. Sine theta will be given by y over r. Cosine theta will be given by x over r. And lastly, tangent theta is equal to y over x. We are now going to talk about how do we use CAST, or ASTC. So when we label this, we're going to call it A, S, T, and C. What this tells us is that in each quadrant, this will give us the trig ratio where it's going to be positive. So in quadrant 1, all of them are going to be positive. So all sine, cosine, and tangent will all have positive ratios. In the second quadrant, only sine is going to have positive ratio. In the third quadrant, only tangent. And in the fourth quadrant, only cosine will have positive ratios. Now we sometimes use the acronym CAST to remember it, C-A-S-T. Otherwise, if you want to follow in quadrants 1, 2, 3, 4, then we use ASTC. Another way to remember ASTC, you can also read it as the following. ASTC can be all students take calculus. Although that may not always be true, but ideally we do prefer students to take calculus because we love math so much. All right, let's take a look at an example here. So, given that sine theta is equal to negative 3 over 5, and it's also going to be in quadrant 4, find the other trig ratios. In this example here, we're going to also look for cosine and tangent. Now, some teachers might ask you to find the reciprocal trig ratios, like secant, cosecant, and cotangent, but in order to do that, you need to find the basic three first. So first of all, let's list down what do we know. Sine theta, right now, is equal to negative 3 over 5. And as we mentioned earlier, sine theta is y over r. Something to keep in mind here is that r is the hypotenuse, and that is always going to be positive, which means here that y has to be equal to negative 3 and r has to be equal to 5. We then use ASTC to try and figure out which quadrant it's supposed to be in. Use ASTC here and we take a look. It is mentioned here that it is in quadrant 4. So here we can just draw the triangle. So we get something that looks like this. A rough sketch is fine, just to get the idea there. We'll just draw a rough sketch, right triangle, y is going to be negative 3, and r is going to be 5. Again, you can use the Pythagoras or the Pythagorean theorem to find the last missing side, or you can just notice that because this is a 3, 4, 5 patterned right triangle, we know that this has to be a value of 4. And because x is going to the right side, we know that's going to be positive 4. If x is going to the left, then of course that means x is going to be negative. So now that I have my three sides, I know what x is. So x is going to be 4. We can now easily find the other trig ratios, which means that cosine theta in this scenario, remember cosine theta was x over r, which means that we have 4 over 5. And lastly, tangent was going to be y over x, which means it's going to be negative 3 over 4. And of course, you can then use all this information to find a reciprocal trig if you wanted to. But the key part here is that you're able to find what x, y, and r are going to be. Once you have that information, you can solve your questions quite easily. In the earlier question, we didn't really use ASTC to its fullest potential because of the way the question was worded. So let's take a look at this question here. That's another common one. So here it says that tangent theta is equal to 3 over 4. And we need to find theta in such a way that theta is located between 0 and 360 degrees. Now sometimes they also might ask you for in radians from 0 to 2 pi. So please refer to our other video about how to convert degrees to radians. All right, so for this one here, let's take a look. We're going to do ASTC again, or CAST, whichever you prefer. And we have mentioned here that tangent theta is equal to 3 over 4, which means that it is positive, meaning that it must be in quadrants 1 or 3, because that's where tangent will give you a positive ratio. So here, normally we'll tell students to draw out your triangles to show your work. So again, just rough sketches of your triangles. So one's going to be over here, like so, and the other one's going to be over here. So now we know that we're looking for this angle here, and also this angle here. So your two answers are going to be in quadrants 1 and 3. So again, you can first solve for theta, given that tangent theta is equal to 3 over 4. Again, what you can do here is just take inverse tangent of both sides. So theta would equal to inverse tangent of 3/4. Again, we're in degree mode, so make sure your calculator is in degree mode, because if you're in radians or gradians, you get totally different answers. So we go inverse tangent 3 over 4. And we're going to get 36.869, so on and so forth. We're going to round it to the nearest degree to make it a little bit easier. So we'll just call that 37 degrees, just to make it nice and a whole number. Now that's going to be in quadrant 1. We mentioned here that we can then use this angle to find it in quadrant 3. Quadrant 1 is always going to be your reference angle. So again, you can use your reference angle to find every other angle in all the other quadrants. So in quadrant 3, that means that our angle is going to be theta equaling to 37 degrees plus 180 degrees, which means that theta will then give us 217 degrees as our answer in quadrant 3. So in actuality, your two answers are going to be based off of this right angle here and also this angle here. As a last reminder, ASTC will always tell us that when we're trying to solve for trig between 0 to 360 degrees, that we're going to have two answers to look for. So keep in mind that whenever you need to look for theta, look at the domain for theta, and then think about if I use CAST or ASTC, where are my angles going to be? Where is those solutions going to be? Am I going to have 1 or 2 or 3, depending how far theta goes. I hope this video has helped you figure out how to use CAST. Make sure to smash that like button if it helped you, and also please support us by subscribing to the channel and keep increasing your math knowledge. I'll see you in the next video. Bye.